we are moving on. We spent the last several days solving quadratic equations, and when you solve a quadratic equation, what are you solving for? The x-intercepts of the parabola. Okay, Sam? The x-intercepts of the parabola. So CO56 is basically the reverse of PO55. It's where I'm giving you the x-intercepts of the parabola, and your job is to write the original equation. So you can use the equation to solve for the x-intercepts. You can also use the x-intercepts to get back to the original equation. Okay. So this right here is a breakdown of what we did in PO55. It's where I gave you an equation such as x squared plus 15x plus 56. You set y equal to 0 because we're solving for the x-intercept. You factored it, got x plus 7 and x plus 8, and then the x-intercepts as a result of that, what value for x makes this equal to 0? Negative 7 plus 7 equals 0, and negative 8 plus 8 equals 0, and those are the x-intercepts of the parabola. That's what you did in PO55, okay? In CO56, we're going backwards, like I said. If I give you the x-intercepts, if I tell you that the parabola crosses through the x-axis at negative 7 and negative 8, how you build back to the equation is first, if the x-intercept is negative 7, what does that tell you about the parentheses that that value came from? It means that this negative 7 came from x plus 7. And this negative 8 came from x plus 8. Right? Because these values represent the values that made whatever set of parentheses that they came from equal to 0. And then, how do we get from x plus 7 times x plus 8 to our original equation of x squared plus 15x plus 56? Foil, crab claw, box. Okay. I wrote this before I officially taught the box method for that. Okay. So foil, crab claw, box it, and then rewrite it in standard form. Y equals ax squared plus bx plus c. And you can check these answers also, like we talked about before. If you plug in negative 7 in for x in this equation, in for both x's, does negative 7 squared plus 15 times negative 7 plus 56 equals 0? Yes, it does. Negative 8, it's the same thing. Okay? So you've done all this math before. You've foiled, you've crab clawed, you've boxed. Okay? You've understood what the x-intercepts, how we get them. It's just reversing that thinking and going backwards. Okay? You know how to get to school from your house. Can you get from your house from school? That's that right? Yeah. Going backwards. Okay, yes.
Oh, so you crab out a box of foil that x plus 7.
And x plus 8, yes. Yep. Okay, so going down to the examples here, we're just going to get rolling. X equals 4 and x equals 7. These being the x-intercepts of the parabola, what set of parentheses, what expression would have given us that 4? Colon.
Subtraction.
What would be in the parentheses?
Oh, x minus 4.
X minus 4. And we know that because 4 minus 4 equals 0, right? That 4 is what makes that set of parentheses equal to 0. What would our second set be, where an x-intercept of 7 would be the solution? Leo. X minus 7. Okay? Once you have your two sets of parentheses to get back to that trinomial, again, this is CO48, you foil, you crab claw, you box. Someone who's confident in their answer, what do you come up with after foiling, crab clawing, boxing here? Nathan.
X to the second plus 11x.
Minus 1.
Wait, do you want me to like? Oh, it's
Plus 28.
minus?
Did you put x plus 4 and x plus 7 in here? Yeah, so the reason why that doesn't work is if you put x plus 4 as your parentheses, if you plug in 4 for x, does that make it equal to 0? No. 4 plus 4 is not 0. 4 plus 4 is 8. Okay? The parentheses that these come from, this 4 made the expression 0, which means it's 4 minus 4. Okay? And x minus 7. They're the opposite of what was in the original parentheses. So it is a negative 11x. but it is still a positive 28 because negative times a negative makes a positive. And again, I got that from foiling, crab clawing, boxing, back to PO48. And then we just want to write this as a parabolic equation in standard form, which all that means is put a y out in front of it. Y equals ax squared plus bx plus c. Okay? So if you were to graph that parabola, you know it would cross the x-intercept at 4 and 7. Now, what's the value of knowing the x-intercepts? If we know it, and you don't have to write this down yet, we'll cover this again, but just so you know, why are we doing this? Why do we care? Why does this matter? If you have a parabola that you know crosses the x-axis at 4 and at 7, remember what we know about parabolas. What direction does this parabola open? It opens up, and we know that because it's positive here, right? So that means our vertex is going to be down here somewhere. Who can tell me more precisely where the vertex of this parabola is going to be? Colin.
I know how to get it.
Negative b over 2a, right? But I'm not looking for an exact point. But let me put it this way: who can tell me where the axis of symmetry is going to go through the x-axis?
The middle of 4 and 7.
The middle of 4 and 7, right? Because a parabola is symmetrical between 4 and 7, 5.5. Right? That's where the axis of symmetry is going to go between. So knowing the x-intercepts, it gives you a shape of what this parabola is going to look like. Is this a wide parabola? Is it a narrow parabola?
I don't know.
It's fairly narrow, right? And so where we're going with this, why we care about this, is that we're everything that we're doing is designed to give us information about the parabola. The x-intercepts, they give us information that can allow us to make other conclusions, right, based on what we know about parabolas. Okay. So anyway, that's why we care. Now, the next one here, x equals 3/4 and x equals negative 9/4. This one's a little bit tricky, but remember that negative b over a shortcut that we took before. What would these x-intercepts be in their original expressions? And you've got two options you can go with here. One, if you like fractions, you can go that route. The other, if you don't, you can go that route. Paul.
Is it 4x minus 3?
Okay, so remember this denominator, that's your a, that's your coefficient. That's going to go first. And then that positive 3 means it was negative 3 in the parentheses. The opposite of b is positive 3 divided by the coefficient divided by a. That's where the 4 comes from there. So again, that reverse thinking, right? Those of you that like that shortcut of negative b over a, you can use that, again, reverse to get the original expression. What would negative 9/4 be? Oh.
4x plus 9.
Again, that denominator is our coefficients, and then our constant this time is going to be positive, because to get that negative, it would have been positive in the original expression. Okay? Yeah?
Could it also be negative 4x?
It could also be that second set of parentheses, because it doesn't matter where that negative sign goes. Is it with the 9? Is it with the 4? It could be with either. You could also write negative 4x minus 9, because the opposite of negative 9 is positive 9, divided by negative 4 would still get you a negative 9/4 parentheses. Okay? If this doesn't quite click, it's a lot of negativity.
No.
Colin, you're having a rough day today? Okay? Kidding. But it works. Okay? Yeah.
So you're saying that we can use both?
You can use either. You don't need to use both. You use either. Okay? Yes, Andrea.
Would the b in that equation be positive 24x?
What's up?
Would the b in that equation be positive 24x?
Yes, it ends up being positive 24x. Yet a third option, you could also do x minus 3/4 and x plus 9/4. Okay? Why that works is because 3/4 minus 3/4 equals 0, and negative 9/4 plus 9/4 equals 0. Now the downside of this is foil crab climb boxing becomes a little bit more of an issue because of the fractions, the operations with fractions, but it does work. You will get the same quadratic equation or an equivalent quadratic equation as a result. But you do still have to multiply the 3/4 and 9/4 and the FOIL capital box. That process is the same. So if you like fractions, this might be easier to go with. If you don't like fractions, this is easier to go with here. Focus on that negative b over a. And this middle one is an alternative one to the first one. But I would just stick with what makes the most sense. Okay, Nick? You do, yes. Otherwise, yeah, everyone would just do this bottom one here and call it good. You still need a FOIL, you still need to calculate, you still need to box.
Mr. Schultz.
Okay. Yeah.
Can you just take like the 4 from the fraction on the bottom one, the 4 from the fraction, just move it over and then make it a 3?
Say it one more time.
So it'd be 4x minus 3 on the bottom one, the bottom left.
Here?
Yeah.
Well, yeah, that's what we had up here.
Okay, so
Yeah.
pretty much that's what we did.
Yes.
I kind of got lost.
Yes. This is the bottom one here is a different option than the first one. It's not like I got from here down like I didn't simplify it. This is our separate ways to do it.
Yeah.
Okay, so don't try and do both of them. Pick one and go that route. Okay. How about the last one? Tell me what you know about this quadratic equation here. What do you know about it just by looking at it? By looking at its x-intercepts. Foltinsky. What do you know? Okay, Colin?
One of them is 0, so it's going to be an x squared.
Okay, because you have that x-intercept of 0, you know it's got to be in ax squared plus bx form. Right? That x-intercept of 0, you know it has to be in ax squared plus bx form. Which, if you remember, means you've got something on the outside of parentheses and then an expression inside of parentheses. Right? What's going to go on the outside here? 0. Just x. Okay? Just x. Because what value for x makes it 0? 0 does. And then what expression is going in our second set? I made this first set shorter because all we have to put it is an x. What goes in that second set of parentheses?
X minus 10.
X plus 10. What value for x makes this 0? Negative 10 does. That's why negative 10 is the x-intercept, and this is the parentheses that it came from. Because negative 10 makes that set equal to 0. That's what it's all about. What value for x makes it 0? Since the x-intercept is negative 10, the original expression in the parentheses is x plus 10. Okay? Then, to put this into a quadratic equation, distribute that x into the parentheses, and we get x squared plus 10x equals 0, or y equals x squared plus 10x. Okay? Yeah?
2 things. 1, are you going to make this do the back
Yes.
Yes, yes.
And 2, will you get points knocked out if you don't put it directly in y equals x?
Yes, you do need to put it in this form here. Yep, that should be your final answer. Colin.
I did it with 2 terms of each parentheses, but I did x plus 0.
Same thing. Yep. X plus 0 is a replacement for x. That's totally fine. Yeah.
Can I still put x plus 0?
That's
Oh, wait,
what I
that's
said.
Yep, that'll work too.
How do you not know 8 times 8? Do you not know you said
Okay.
You didn't know it either. Yeah. You may know it.
Any on the back side you want to go over? Well, all of them is not going to be feasible. Chase.
Negative 3/10 and negative 1.
Okay. So since these are negative in the fractions here, what symbol is going to be in our sets of parentheses?
A plus.
A plus. Okay? If the x-intercept is negative, that means you're adding in the parentheses because the opposite of addition is negativity. The opposite of positivity is negativity. And remember, these x-intercepts are the opposite of what you have in the parentheses. Okay? That 10 is significant. That 10 represents our coefficients. And that numerator is the constant, 10x plus 3.
Then what do you
right? If you think about it the way that you're in CO55, it checks out. The opposite of our constant, the opposite of positive 3 is a negative 3 divided by coefficient 10. What would be in our second set? Cool.
4x plus 1.
4x plus 1. Okay? And then you're left with foiling, crab clawing, boxing that, which if you do it right, I'm not going to show my work in the interest of time here, but 10x times 4x is 40x squared. My inside outside, 12x here, 11x there, or sorry, 10x there. Ooh, that was almost a disaster. 22x, and then 3 times 1, my constants, plus 3. So your final answer is y equals 40x squared plus 22x plus 3.
Can we do this for homework?
Okay? I think you can do this for homework.
Yeah.
Well, ask the question. Naveen, what's your question? What do you want to go over?
Well, like, stuff with the 1 to the 0. Cool. At the end, like,
Yeah. All that means, all you do with this x equals 0 is put an x in front of your parentheses where that one goes in, right? Because in this form, that x equals 0, we know it's got to be ax squared plus bx form, which means you've got something outside of parentheses that you factored out. Okay, we can represent that with an x. This one is going to be 5x minus 6. Since it's positive, it's going to be a negative 6 in the parentheses. 5 is the coefficient, 6 is the constant. And because to get from here to our x-intercepts, we factor out, right? To get back to our equation, we're going to distribute back in. And that gives us 5x squared minus 6x as a final answer. So when you see that x equals 0, it just means there's an x out in front, and then your parentheses contain the other value there.
Please tell me this. Yeah, it's so.
Yes?
So like, let's say we had one of these that ended up being the same answer as like more from the 55.
Ooh. Yeah, it could happen.
Please say this is homework.
Yeah. It wouldn't be intentional, but it's possible. Okay? All right, folks, I gotta let you go. Home tomorrow. Have a wonderful day. So long.